This is the week 10 throwback assignment. Before I get started working on it, I want to show you this chart as a little bit of a refresher. What this chart shows you is how you convert between a bunch of different things. So if, for instance, you want to go between mass and moles, you use the molar mass. If you want to go between moles and particles, which are atoms or molecules, you use Avogadro's number, 6.02 times 10 to the 23rd. Moles to volume, 22.4 is the conversion factor. If you're going particles to particles or moles to moles or volume to volume, you use that mole ratio. Before you get started on this assignment, you'll either want to copy this down or try and rededicate it to memory or something, because you're going to need to know all of these relationships to understand what's coming along. Alright, so here on questions 1 through 3, the first thing that I think it would be useful to do is figure out what things I'm going to need to know the molar mass of, because that way I can just calculate those ahead of time and then just plug them in when I need them. So what I do is I look through and I see on question 1 here, it says grams of aluminum. Okay, so I know, aluminum oxide, so I know I'm going to have to find the mass of that. On question 3, it says grams of oxygen and grams of aluminum. So actually in this problem, I'm going to have to find the molar mass of all of the different substances. So if you look it up on the periodic table, you can find that the molar mass of aluminum is equal to 26.98 grams. The molar mass of oxygen is equal to 32.00 grams. And the molar mass of aluminum oxide is equal to 101.96. Alright, so we will use those numbers in our calculations, and so it's just kind of handy to have those figured out ahead of time, and so then we can put away our periodic table until we get to the next set of problems. So this first one is asking about how many grams of aluminum oxide would form if we had 12.5 moles of aluminum. So what we're starting here with is moles of aluminum. We're trying to get to grams of aluminum oxide. And so I try and make a little chart here. So if we're starting with moles of aluminum, and then we're going to go to moles of aluminum oxide. Okay, and then we're going to go to grams of aluminum oxide. So that's kind of our pathway that we're going to take on this one. And then also, I try and write in conversion factors. So conversion factor mole to mole is the ratio. All right, and then from grams to moles, we're going to use our molar mass there. And so that's how that works. All right, and then I'll just start the conversion over here. If we've got 12.5 moles of aluminum, and if you look at, the ratio comes from the coefficients, so we've got 4 moles of aluminum for every 2 moles of aluminum oxide. We know 4 moles of aluminum, so it cancels out. It'll go on the bottom. For every 2 moles of aluminum oxide. And then the last step here, we're going to go from moles of aluminum oxide to grams of aluminum oxide. So in every 1 mole of Al2O3, there are 101.96 grams of Al2O3. Multiply all this together. You're going to want to round to 3 sig figs because our original number here had 3 sig figs. And if we look through, the mole ratio is a perfect sort of infinite sig fig numbers, where it says 1 mole for the molar mass. That's sort of a perfect sig fig number. And so 3 is the smallest number of sig figs, so that's what our answer should have. Put that through, you should get 637 grams of Al2O3. All right, for problem number 2, we're going to do something similar. This time we're given moles of aluminum, and it's asking us how many liters of oxygen are going to be produced. So we start with moles of Al, and then we want to get to moles of O2, and then we want to get to liters of O2. All right, moles to moles, that's a ratio, is the conversion factor. Moles to liters, assuming STP, 22.4 is our conversion factor, 22.4 liters in 1 mole. So then we go through and we write it out. 7.5 moles of Al. Looking at the balanced chemical equation, we see 4 moles Al, 3 moles O2. All right. And then for every 1 mole of O2 we have, it is 22.4 liters. If you look at this problem, we have 2 sig figs. So go through, multiply across everything on the top, divide by everything on the bottom. You should get, now your calculator will spit out something like 126, but rounding to 2 sig figs, 130 liters is what I get out of there. And we'll say liters of O2. Question number 3, how many grams of oxygen are needed to react with 100 grams of aluminum? So this is a gram to gram problem. We're starting here with grams of Al, and then we're going to moles of Al, and then we'll go to moles of O2, and then we will go 2 grams of O2. So writing this all out, we start here, 100 grams of Al. The molar mass of Al from up above, 26.98 grams of Al in 1 mole of Al. Looking at the balanced chemical equation, you see that there are 4 moles of Al for every 3 moles of O2. All right. Now going with the molar mass of oxygen, every 1 mole of O2 has a mass of 32.00 grams. We multiply all that together. If you look around, actually this 100 originally should be 100.0 because that's how it's given in the problem. We have 4 sig figs all the way around, okay? Or things that have infinitely many sig figs. And so our answer should have 4 sig figs. If you put that through, you should get something like 88.95 grams. All right, on to our second equation here. So again, I think it's handy just to kind of figure out what molar masses we're going to need here. So I'll look at where grams are involved. I see here we've got a number of grams of C3H8, so we're going to need to find the molar mass of that. And then I see grams of water here is something we're going to need to know the molar mass of. So going through and calculating those, I get molar mass of C3H8 that's equal to 44.11 grams. The molar mass of water is equal to 18.02 grams. And that's all the molar masses we should need. So I'm going to go through now, perform these calculations. This first one here starts out with molecules of carbon dioxide. Oh, sorry, it's asking for molecules of carbon dioxide. It starts out with grams of C3H8. So we need to go from grams of C3H8 to moles of C3H8. And from there we can go to moles of carbon dioxide. And from there we can go to molecules of carbon dioxide. Conversion factors here, grams to moles is the molar mass. Moles to moles is the ratio. Moles to molecules, that's Avogadro's number, 6.02 times 10 to the 23rd. All right. Now we're ready to sort of start plugging things in here. Starting out with 25.8 grams of C3H8. And then there are 44.11 grams of C3H8 in 1 mole of C3H8. And then looking at the balanced chemical equation to get the ratio, you see that there is 1 mole of C3H8 for every 3 moles of carbon dioxide. Now we need to get it to molecules, so as I said there, for every 1 mole of CO2, we have 6.02 times 10 to the 23rd molecule CO2. Go through, calculate all of that. It looks like 3 sig figs all the way throughout. You should get 1.06 times 10 to the 24th molecule CO2. All right, last problem here, starting out with 30 liters of oxygen. We're going to get to grams of water. So on this one, we're going from liters of O2 to moles of O2 to moles of water, and then 2 grams of water. Liters to moles, that's 22.4 is your conversion factor. Moles to moles, that's using a ratio. Going from moles to grams, that's using our molar mass. So starting out here, 30.0 liters of O2. There are 22.4 liters of O2 in 1 mole of O2. Looking at the balanced chemical equation, we see that for every 5 moles of O2, there are 4 moles of water. All right, and then last step here, going from moles of water to grams of water. For every 1 mole of H2O we have, there is 18.02 grams. Go ahead, write that all out. You should find that we get 19.3 grams of O2. All right, that is that. I know stoichiometry is pretty complicated, and it's been a while since we've done it. If there's any questions you have on this one, try and come in and talk to me about it. Otherwise, just look through these. There's more practice you can probably find online. Just make sure that you're on top of that, and watch your sig figs too, because there will be some answers on there that have the wrong number of sig figs, and you need to work that out. So let me know.